Hello everyone, welcome to Biology. This is Dr. Asim Shabbir and we are discussing water potential today. This is one of the confusing topics of first year 14th chapter. I hope that after watching this video, you will have a very nice grip on this topic. So I will try to make it easy for you. Let's kick it off. Water potential by definition is the kinetic energy possessed by the water molecules with the help of which they are all the time in the random motion. They are colliding with the walls of container. So technically it's just the kinetic energy present in the water molecules. Water potential is denoted as psi W and it is dependent on two factors. One is the pressure potential, the other one is the solute potential. And we can write it in the form of an equation that psi W is equal to psi P plus psi S. Psi P is the pressure potential and psi S is the solute potential. So we have to discuss about all these three things, I mean water potential, pressure potential and solute potential in detail.
Psi P, that is the pressure potential, is basically the pressure exerted by the water molecules on the walls of container, or in biological terms, you can say that the pressure exerted on the plant cell walls maybe.
That is called as the pressure potential. Now let's talk about the solute potential. Solute potential by definition is the drop in the water potential by the addition of solute molecules in water. Let's talk about this in physical terms. Let's say we are adding some solute in the water, and that solute is going to have the forces of attraction with the water molecules, and because of those forces, now the random motion of water molecules is going to drop. The water molecules will now not be that free like how they were before. So that drop in the motion of water molecules or in the kinetic energy of water molecules is called as solute potential. If I say that the water molecules are having low kinetic energy, it means they now have less water potential. So by the addition of solute, you are decreasing the water motion or the water potential. So that's the basic theme of solute potential. Now the next important point is the relationship of solute potential with solute concentration. And this relationship, as you can see in the expression, the solute potential psi S is related to the negative of solute concentration. So it means that if I am increasing the right hand side, it means if I am increasing the solute concentration, the left hand side, that's the solute potential, is going to drop. So that is how they are inversely proportional. I can also say through some other expression, that is solute potential is inversely related to the solute concentration. The more the solute you're adding, the lesser the solute potential would become. This whole relationship is happening because of the negative sign. It means if you are increasing the solute concentration, the value of solute potential will become more and more negative. And more negative value means lesser value. So we have to relate it with the negative sign. That's the whole confusing point. If you understand it, you understand half of the topic. So now we know that solute potential and solute concentration are inversely proportional. Now we also need to know some of the expression here. So let's look back at the equation we talked about previously, that psi W is equal to psi P plus psi S. Based upon this equation, I can straightaway say that psi W is directly proportional to psi P, and similarly psi W is directly proportional to psi S. It means that if you have higher solute potential, you will have higher water potential and vice versa. So let's say if there is a solution which has less solute potential, it will have less water potential. We can also talk about this thing in terms of solute concentration. If you are adding more solute to a solution, it means you are increasing the solute concentration. By increase in the solute concentration, there will be drop in the solute potential because they are inversely proportional. And similarly, if the solute potential is dropped, the water potential is also dropped, because now these two, I mean the solute potential and the water potential, are directly proportional. And this leads us to a fact that higher the solute concentration, the lesser the water potential would be. And this is something we had been discussing previously in the definition of solute potential, that if you're adding more solute to a solution, you are going to drop the water potential. Now we are discussing about this very thing in mathematical terms. So let's take an example here. This is an example from your book in which there are numerous numerical values are given. There is an A cell and there's a B cell, there are two cells which are present adjacent to each other, and these two cells have different values of water potential, pressure potential, and the solute potential. I'm writing all these values in front of you. As you can see that the cell A has water potential as minus 1200 and the cell B has water potential of minus 800. As you can see, the values of pressure potentials are 800 for cell A and 600 for cell B. The value of solute potential being negative 2000 for cell A and negative 1400 for cell B. Now, before jumping into the calculations, I want to remind you the relationship of the solute potential and the solute concentration. The solute concentration and the solute potential are inversely proportional. So we have to define that which of these two cells have higher solute concentration and higher solute potential and vice versa. I mean, if you see the values of solute potentials of cell A and B, you can see for cell A it's negative 2000 and for cell B it's negative 1400. Now you can easily tell me which one is the higher, which one is a lower value. And it goes without saying that the cell B has higher value of solute potential and the cell A has lower value of solute potential because it is lower, it is more negative value. Negative 2000 is more negative value, so this is a lesser or lower value. Now if we say that the solute potential of cell A is lower, this automatically tells us that the solute concentration in cell A will be higher and the solute concentration in the cell B will be lower. Now there is something that is really important to have the concepts of many topics right, and that is solvent follows solute. It means wherever the solute is higher in concentration, water will go there. Solvent means water, so water will go wherever the solute is higher in concentration. So please remember, I'm talking about the solute concentration now, not the solute potential. All right, because these two things are inverse. So I'm saying if we talk about the water movement in this given picture, that where will the water go? Will it go from A to B or B to A? And I know by now all of you have figured out that the water is going to go from the cell B towards the cell A because the cell A has higher solute concentration. Again, it has higher solute concentration. That is why the water is going towards the cell A. So don't be misled by the solute potential and the solute concentration. They are two different entities. So now as we have defined the water movement, we can get number of other results too. So number one result is if you see between A and B cells, which of them has higher water potential, and it's easy to see that minus 800 is a bigger value as compared to minus 1200. So cell B has higher water potential and cell A has lower water potential. So this is an information we are given here that the water is going towards that cell A. We can also say that water is moving from its higher water potential towards its lower water potential. This is the definition of osmosis, that water moves from its higher water potential towards its lower water potential. So there are basically two things which are very important to understand in this topic. One of them is that water moves towards the higher solute concentration, and the other one is that water moves from its higher water potential towards its lower water potential. So in the end, I want you to focus on one thing, that the water potential of the pure water should be maximum, because it makes sense that the water molecules which are all free, which are not bound by any solute, they have the maximum random motion, they have the maximum kinetic energy. So that is why they have the highest water potential. And for a standard, or you can say just for a reference, we say the maximum or highest value of water potential could be 0. This does not mean that the kinetic energy of water molecules is getting 0, but this is just for the reference or just for setting the standard. All right, now if the water potential, maximum water potential is for free water or the pure water and it's 0, that means whenever you will add a solute in the water, it means whenever you will make the solution, its water potential is going to be in negatives, because you know that the solutions have solute in it and solute molecules are binding the water and they are dropping the water potential. And because of that, if you go before 0, I mean if you have to drop the value from 0 level, you have to go in the negatives. That is why the water potential of solutions is always in negative. So this was all about water potential. I hope you liked it, and I will see you in the next lecture. Thank you very much.